Hi, this is Mr. Franklin, and this is a video key for electromagnetic induction, page 11. Number one, electromagnetic induction is the ability of a moving magnetic field to create a current. And current, as we may or may not remember, is moving charge. So a moving magnetic field can create moving charge, also known as current. What's the definition of magnetic flux? Now, because we're not really getting into the math, some of this may not make as much sense as it does if you do get into all the math. Magnetic flux is the amount of magnetic field lines passing through an area. So earlier in the other video, I showed you, we talked about the strength of a magnet is stronger here because all the field lines are bunched together. Well, that's actually one way of looking at magnetic flux. We have a bunch of field lines passing through an area. And that's what this drawing is representing. Inside this little circle, there's a surface area. So if I were to draw that circle and I looking straight down on it, so right now this circle is kind of like turned to the side. Like if you were looking at like a quarter and you turned it and looked at the edge, and now I'm looking at the face. Okay, so this is the edge and this is the face. Okay, so, and this is what makes magnetism a little difficult to talk about, is because it's a three-dimensional thing. It happens in 3D. Anyway, we have this loop of wire. It's a wire, and we're going to have magnetic field lines. And I'm going to draw a circle with a dot. We'll pretend they're all the same size. These field lines are coming out at you straight, like in 3D. They're coming out of the screen towards you. So if you were to put the eraser end of your pencil and have the pointing of the end of your pencil pointing at your face, that's what these magnetic field lines would be doing. They would be coming out of the screen towards your face. Okay? And so the more of these little dots, more of these field lines we have, the magnetic flux gets stronger. Well, if we take this electromagnetic induction is moving magnetic field creates a current. A moving current creates a magnetic field. So that's induction. We take both of those concepts and then we use magnetic flux, and we actually cause a changing magnetic field. So we cause these arrows. We cause how many arrows here? We cause them to change, and that actually creates electricity in this piece of loop. So then we would get a current going around this wire if we start changing these. Okay, so anyway, this is a loop, and you got these field lines going through it. Okay, in a different color or pattern, draw what happens to the arrows when the magnetic field is doubled. So we have 3 lines, and now we have 6 lines. That's it. That's magnetic flux. Small magnetic flux, large magnetic flux. More field lines through the same size of a loop. Describe what happens when the wire loop is rotated. So if I take this loop, so this is one way we can do this. There's many ways. If I take this loop and put it on a spinner, and I can cause this end to go like that, and this end to go like that. So eventually I will have this loop perpendicular, but it'll keep spinning. If I can keep spinning it until it's back like this, keep spinning it. That's one way to make it look like this field stuff is changing, and we'll get electricity going around this loop. Okay? So as the loop is rotated, the number of field lines reduces to 0 when the loop is parallel. So when we're parallel with the lines, the loop is flat. So are there any lines going through it? No. But as it turns more, then the field lines are going through it again. Okay? So as the loop is rotated, the number of field lines reduces to 0, and then when it's perpendicular, the field lines is at maximum. And this is called alternating. This generates alternating current. Okay? Why are many loops of wire used rather than a single loop? The more loops amplifies the effect from the field, because each loop feels the effect and it all adds together. Describe what part of a generator in a dam does. So this is, we're talking like the Hoover Dam. So we've got, if you're seeing the picture, we've got the Hoover Dam, and you got some rocks, and then back here you got some water. Okay, some more rocks. And then down here, we have an opening, and the water can spill out. Okay, so how does this work? So the water provides kinetic energy. So we actually use potential energy. So gravity holds it up, and then we open this door, and it turns into kinetic energy. As this water moves now, the kinetic energy causes a mechanical wheel to actually rotate. Well, this wheel is connected to the equivalent of this kind of a loop, and this magnetic flux converts this kinetic energy into a magnetic motion. So kinetic energy is the energy of a moving particle. So now we have a moving magnetic field, and then this causes electrons in the wire to move, and this moving electrons is called current, which is called electricity. So water goes over the water wheel turns a thing, this thing turns in the magnetic field, this magnetic field causes the electrons in the wire, there's a magnetic force on the electrons, and it causes the electrons to move, and we have electricity. There's a lot more to it. It's one of my favorite topics, but that's about as deep as we're going to get into it. So that concludes this little key to page 11.